So today you are going to be learning lesson 3.7, which is the distributive property. By the end of the lesson, you should be able to apply the distributive property to expand and simplify polynomial expressions. Before I talk about the distributive property, I want to just go back to a couple of fundamentals that I think you need for this lesson. And I'll just write this on the top. If I ask you, what is x plus x? You're going to tell me that that's 2x, right? 1x plus 1x is 2x. If I ask you, what is x times x? And sometimes we use a dot in the middle to denote times, so maybe I'll do that. Hopefully you're going to be able to tell me, oh, that's like a power, and I add the exponents of a power, and I get x squared. Okay? You need to be able to distinguish those two fundamentals. When you're adding two like terms, you just add the numbers and you keep the term itself the same. Or the variable the same. If you are multiplying, it changes. It changes the variable. Okay, if I multiply x times x, I get x squared. It's a new variable. If I multiply x times y, I get something new called xy. But when I add 2, I don't get anything new. It's still an x. It's just the number of x's that change. So I call this a fruit salad. When you're adding all kinds of different fruits together, you get a fruit salad. You get a bunch of different apples, you get a bunch of different strawberries, you get a bunch of different bananas, but it's a mixture of all those things. It's a fruit salad. You can still see all of the apples, all of the strawberries, all of the bananas. When you're multiplying, this is like a smoothie. You're throwing a whole bunch of things in there and you get something different. If you throw in a couple of strawberries, yeah, you're still getting strawberries, but they look different, right? They're all blended up. If you throw in a strawberry and a banana, you're getting something that looks entirely different. Okay? So adding, you're creating a fruit salad. Multiplying, you're making a smoothie. If you can kind of think about that in those terms, you should be good. Because what happens in the distributive law is that we do add and we multiply. And so the rules have to be clear in your mind. Okay, so the distributive property is used to find the product of a monomial and a polynomial. Well, there's a monomial. This is A. That's just a monomial. And this polynomial is specifically a binomial. So the rule says you take the monomial and you multiply it by what's inside the brackets. So A times B is AB, smoothie. A times C is AC. And the same is true if you had something that was being subtracted inside. Nothing changes. It's A times B, and then instead of plus AC, it's minus AC. That's all. No big deal. Okay. So the first example is it says expand. So we're going to take 6x times x. Well, we know that 6x times x is just, if we look at 6x times x, going back to our little analogy up here, these are powers with an exponent of 1. We're not adding these, we're multiplying. So we take the number times the number and the power times the power and add the exponents. So this would be 6 times 1, which is 6. X times x, which is x to the 1 plus 1, which is x squared. So the first term, when I do 6x times x, that's going to give me 6x squared. The second term, when I multiply 6x times minus 4, 6x times minus 4, 6 times minus 4 is minus 24, and x times nothing over there, so it's like x times 1 really, or x times, 1 is x. So we get 6x squared minus 24x. Now we have to ask ourselves, can we combine these two into something simpler? And the answer is no. Think about our fruit salad. We have x squareds, we have x. We cannot combine these. These are not the same. So we just leave it as part of our little fruit salad. Okay? All right. Let's go to example 2. 8 times x minus 3. So it says expand and simplify. So we're just going to do 8 times x and 8 times minus 3. That's pretty easy. 8 times x is 8x. And 8 times minus 3 is minus 24. Can't combine those two because this doesn't have an x attached to it, right? So this is as simplified as it can be. We don't always work out that nicely. So let's see. Minus 3 times 2x, well, you just multiply the numbers. So this is going to be minus 6 and x. Minus 3 times minus 4, well, that's positive 12. And again, we can't simplify that anymore. A times 3a. Okay, a times a is a squared, right? A to the 1 times a to the 1 is a to the 1 plus 1, which is a to the 2. And then this has got an invisible 1 in front, so 1 times 3 is 3. So this is 3a squared, and then the a times the 2 is positive 2a. You must put the plus there. You can't just have these terms separated by nothing. Okay, so you have to make sure you're putting plus 2 there. Plus 2a. Ooh, this one looks tricky. So we've got all of this, minus 2 and p, all being multiplied by whatever's inside the brackets. So let's see. Minus 2 times p times minus 5p is minus 2 times minus 5, which is positive 10, and p times p, which is p squared. So that's the first term. And then minus 2p times minus 3 is minus 2 times minus 3, that's positive 6. And we've got a p here with nothing over here, no variables, so we just have p. We cannot combine those any further because this is a p and this is a different, unlike term, p squared. Okay, I want you guys to pause the video now and expand and simplify, if you can, these two examples. Okay, so this is going to be 36d minus 28. Done. No more simplifying involved. This one, minus 7t squared minus 5t. So minus 1 times minus 7, minus 1 times 7 is minus 7, and t times t is t squared. That minus looks a little low, but anyway, you know what I mean. It's minus 5t. All right. Steps to remember when it gets more challenging. So don't forget about your BEDMAS rules. Don't forget about adding and subtracting like terms. And don't forget fruit salad versus smoothie, as well as your rules for your powers. Okay, let's see if we can tackle these tricky ones. It says expand and simplify. So the minus 6 here only gets multiplied by whatever's inside that first set of brackets, okay? So we're going to multiply minus 6 times a, so we just put them side by side, minus 6a. And then minus 6 times minus 2b, well, minus 6 times minus 2, do the numbers by the numbers, so that's positive 12. And the letters by the letters, well, there's no letter there, so it's just a b. Over here, there's no number in front. Remember the rules for subtracting polynomials? We drop the brackets and change the sign if there's no number in front and if this is a minus. So this is going to be minus 2 plus 3b. Another way you can think about this is thinking about this as a minus 1 in front. And you can think about, oh, I'm distributing a minus 1 inside my brackets. So minus 1 times 2 is minus 2, and minus 1 times minus 3b is positive 3b. Please note that you will never have more than one sign in between. If you do, if you end up with a plus minus is a minus. Okay, so if you're adding and a negative, you're really subtracting. Okay, so be careful about that. I only want one sign in between each term. Can I simplify this is the question now, and the answer, of course, is yes. I do have some like terms here. So I have minus 6a plus 12b plus 3b minus 2. So my minus 6a plus 15b minus 2. And just like we told you about the descending order of power, where you want to do the highest exponent down to the lowest exponent, the rules for when you have all the same degree terms, so these are both degree 1 terms here, would be that you express them alphabetically. So do the a first, the b, and then the constant at the end. This is fully simplified now because a and b cannot be combined. One's a strawberry, one's a banana, and we have a fruit salad here because we're adding things together. We're not multiplying. Multiplying gets you a smoothie. All right. Whoa, we've got 4 being multiplied by everything. That's the square bracket. So let's deal inside first. So BEDMAS tells us to deal with these brackets first, but you know what? They're simplified already. 2 minus 3x, you can't simplify it anymore. So I'm going to go outside to the first term outside this bracket. And I can see then that I have to multiply negative x into this bracket, only till the end, till the closed part of the bracket, right? I'm not multiplying negative x by negative 7. So the way you do this is you just leave the 4 like that, and now I'm going to do my minus x times 2, so that's minus 2x. I'm going to do my minus x times my minus 3x. So let's think about this. Minus 1 times minus 3 is positive 3. And x times x is x squared. Remember, x to the 1, x to the 1, you add the exponents. And then I still have this minus 7. It's not being multiplied by the negative x though, so I'll just put it in at the end and close my bracket. Could have changed to a round bracket now that I don't have 2 sets of brackets, but that's okay. Now I'm going to simplify inside my bracket if I can, but I can see that I have all unlike terms. So I'll just go ahead and I'm going to change that, and I'm just going to reorganize this so that it's in descending order of power. I didn't have to do that now. I could do that later, but I'll just do it with the round bracket because that looks better. Now I'm going to do my distributive law with my 4. I'm not finished. Simplified means no brackets. So this time I'm multiplying 4 by everything inside the brackets, the 3 terms. So I'm going to end up with 4 times 3, which is 12x squared minus 8x minus 24. No like terms here, and we are finished. Minus 24, what am I talking about? That's minus 28. I think I'm getting a little tired. Sorry, that's minus 28 there. So let me make sure I did the rest of it properly. Okay, that looks good. All right, we're almost done. You go ahead and try number 3 and 4, please. Pause the video and come back and see if you got it right. Okay, so we've got 5p squared minus 20p. And then this is minus 2p times 8, minus 2 times 8p, which is minus 16p, and plus 22. This is 5p squared, no other p squared, so we're good. We've got 2 p's here, so minus 20 minus 16 is minus 36p, and plus 22. Hopefully you got that right. Ay, look at this one. So again, we've got 3 minus 4 times this. The only thing that 5p minus 1 is being multiplied by is the minus 4. The 3 is not part of the multiplication, and you cannot do 3 minus 1. Because of BEDMAS, you must do the multiplication here before you do the subtraction. Okay? Common mistake would be for somebody to do 3 minus 1 and say that it's minus 1 in front, and then multiply the minus 1 through into the brackets. But that's not correct because of BEDMAS. So we have to do the multiplication first, and only the minus 4 is being multiplied. If this whole thing were being multiplied, there would be a bracket around the whole thing. Okay, so this is going to still be minus 2p. We still have, we're going to end up with a round bracket here, 3, and then we're going to start our multiplication. So minus 4 times 5p is minus 20p. And minus 4 times minus 1 is positive 4. Now I'm going to simplify inside my brackets if I can. I always do that. BEDMAS tells me always work with brackets first. And yeah, I can, right? I can simplify the 3. This is 3 plus 4. So I'm going to have minus 2p times 7 minus 20p. And when I do my distributive law now, I have minus 2 times 7, which is minus 14p and nothing else, so that's just p. And then minus 2p times minus 20p is going to be plus 40, and then the p's multiplied together give you p squared. Now I'm just going to rearrange this so that the p squared is first, because I should be expressing it in descending order of power. Okay, did you get those two right? Those were tricky, that's for sure, especially the second one. All right, last example. It says write an expression for the area of the rectangle. Well, we know that area is equal to length times width, so let's write that down. And we have the length is x plus 7, and the width is 5x. That's interesting. So we've got x plus 7 times the width, which is 5x. Okay. I'm going to rewrite this with the monomial in front, because typically that's what we do. I was just sort of following the formula here and putting the width here, but now that I see it, I really think it's easier to see what to do if we write it with the monomial at the front, which is really what we should be doing. So the area, it says write an expression for the area, expand the expression. So that's part A. Done. Expand the expression. All right, I'm going to go ahead and use my distributive law. That's going to give me 5x times x, which is 5x squared, and 5x times positive 7, which is 35x. So there's my expression expanded. And then we want to find the area when x is 3 centimeters. Whoops. So when x equals 3 centimeters, the area is going to equal 5 times 3 squared plus 35 times 3. And again, we have to be careful with our BEDMAS. This isn't 15 squared. We have to do the exponents first. So 3 squared is 9. 9 times 5 is 45. Plus 35 times 3 is 105. And we get A equals 150. And the units are centimeters squared. Whoops. Okay, area is always squared. Okay, so therefore the area of the square is 150 centimeters squared. Okay, I think that's the end. Let me double check. Oh, that's just the same. Okay, thanks for listening.